But whatever you're displacing, should not be self-powered, just in case it runs out of battery.
I usually keep my phone up like 50%.
I learned that one real quick. Yep, not a good idea.
Oh, it's your weekend.
My weekend?
Yeah.
Interesting. I went to my first field target competition, only to get food poisoned. Yeah.
Fun.
Well, it has to do with either the chili or the salsa that I ate. But nobody else seemed to have any problems. But my Monday was gone, man. I mean, that was like gone. I had a fever, and I was just staying in bed the whole time. I could barely drive my kids to school, and that was about it. On Monday, yesterday. But the competition itself was fun. I got to meet a lot. It's called a field target competition. We shoot air guns, and so we shoot these animal plates. So they use pigs, squirrels, pigeons, wolves and whatnot. So each one is just a plate with a hole behind it, and then there's another plate behind the hole. So when you shoot through the hole, the target will fall, and that counts as 1 point. If the target does not fall and you fire the shot, then it counts for 0 points. So we were at a real shooting range, where people actually shoot their ARs and whatnot. So all the other guys around were shooting their really, really loud guns, and we were just going like that. I think some people can spit louder than our guns. No. These are not airsoft. These are actual pellets, air rifle pellets.
Pellet gun.
Yeah, they're pellet guns.
I have one of those. Break barrel. There's a break barrel where you have to break the barrel down to put it in. Or
no one brought along a brick barrel, so they are all kind of more of the high end type of air guns. We have to shoot something about this big, like the tip of an eraser, at 20 yards or so.
Wow. How many do you actually got into the? How many people got pulled?
There were about 20 people, so it was a good show up.
Have you ever been airsofting? Have you ever been airsoft?
No. That's an entirely different kind of sport.
So you know about it?
I know about it. I watch people. I watch YouTube recordings of airsoft battles.
Oh,
I think that's a little too intense for me.
It's pretty fun, man. Yeah, if you get, I don't have all the gear. I just have a few weapons and army skin or camo from.
But to tell you what, I think that still is a lot better than people just doing gaming, just the first person. You have to be physically there. Yeah, I think it's better than just gaming.
So you shot in the eye.
Yep.
But that's why they have eye protection.
Oh yeah, you need full protection, face protection, eye protection.
Oh, the only reason why I did that is because I wear my glasses, and I had to get something that allows me to wear glasses. Otherwise, I got tired of running around relatively blind with the regular safety glasses. I mean, I still did semi-decent. It's nicer to be able to see people.
Maybe a motorcycle helmet.
Oh yeah, actually, I don't even know where that is. I have lost it. Yeah, exactly.
Paintball is pretty fun too.
Yeah, but the only problem with the main problem with that is it getting on your clothes and stuff like that.
Yeah.
The pellets can be, or the airsoft, or not airsoft, but paintballs can be rather messy, even on or off the field.
Yeah.
All right. Well, let's go ahead and get started with our topic here. With this class, okay, with this class, we are done with explaining the rationale of top-down design. We talked about that. I think the class before the last one, because last class we talked about the practice exam for the exam on this Thursday. So let me first ask, whether there are any questions about the exam on Thursday. Any questions about the format?
I was gonna ask about a question, like a example you can do maybe.
We did that on Thursday.
Well, if you could do another one, you can.
Did another one?
No, if you can do another one.
Does anyone want to do another one? Okay.
What problem in particular?
The pre and post.
The pre and post. Okay. Go ahead.
I tried to look at the video online and there was no audio recording.
That's right, because I did not bring my bag the other day.
No audio.
There's no audio because I did not have my microphone with me on that day.
There was do one more.
Hmm?
We should do one more.
We can do one more? Okay.
We should do.
All right. Well, we can go ahead and do it. Okay, so we're gonna go back to the beginning of this class.
Oh, I know.
We'll pick one more. Yep, go ahead.
Is the one where we do like the sub and forget operations, or is that gonna be on the final exam?
Say again?
The substitution and forget,
Yes.
that's gonna be on the exam too.
Yep. That's your homework assignment due last Thursday.
Okay.
Yep. So that topic is on the exam. Okay. So I do have this file. I don't have any tools to open it unless I download and install 7-zip. And it is not already installed here, so that's okay. We'll go ahead and go to 7-zip and install that. In fact, I'll download the portable version of it, put it onto my external hard drive. Yeah, 7-zip is really useful. It's kind of like Unzip or the zip utility program built into Windows, except this one can deal with a whole lot more formats compared to just the Windows version of zip. And I'm downloading the portable version of this, so I can install it on my external hard drive. So now no matter where I go, I can have it accessible to me.
What's the size of your external hard drive?
What is the size of?
Your external hard drive.
It's a 1 terabyte external hard drive. It's a good size. Just have to make sure that I installed it to the external hard drive. I have one partition just for Windows. Alright, so we'll go ahead and run it. We'll look up downloads. Alright, so this one does have a lot of sub-files. These sub-files, each one, is a particular version of a question. So there are, I think, 4 questions, and then each question also has, variants too. So that's why you see A, B, C, D. Those are all basically sub-variants of a particular question. So if I sort it by name, you will see, for question number 1, it has A, B, C, and then for question number 2, it has A, B, C, D. For question number 3, it has A, B, C, D, and so on. So I can just look at one particular one. We don't have to look at every single possible one. All right, so the first question is a tracing question, at least in this particular exam. Well, what do you think? Okay, first of all, do you want to go over with this particular question? Because I think if you don't want to go over this question, we can move forward and make sure that we have enough time to cover the other questions. On the other hand, if you want to go over this question, we can go ahead and go over it. Go over this one? Okay. All right, so let's go over this particular question. Yep, go ahead.
On line 5 it says end if, but there's no ifs.
Yep, it should be end while. It was a typo.
It was confusing me. I was looking for the if.
Yep, you're right. Yep, I got that. All right, so let's go ahead and trace that. X gets a value of 62. While x is greater than 1, 2. First of all, we fix the indentation. Well, this is a good practice here. How am I going to fix the indentation? Can anyone point out to me which entire block should I indent first? From which line to which line?
3
Yep.
to 6.
36.
From line 3 to line 6. Okay. So I take line 3 to line 6, do one indentation first, and then are there any additional lines or any single line that I need to indent one more?
4.
Line 4, very good. That's it. Very good. All right. Because the indentation part is going to be one question, or at least the part of one question in your exam. All right. So we need one column for comments because we have conditions of the while loop to evaluate, line number, and then we have one single variable in this case, which is just x. The precondition is we don't need to know anything about x, so x can start with an unknown value. On line 1, x gets initialized to a value of 62. On line 2, we have the evaluated condition. X is greater than 1 is true. So where do we go next? We go to line 3, because from line 3 to line 6 is the body of the outer loop. So we go to line 3. Line 3 has its own condition to evaluate, which is x is greater than 3. It is also true, because x has a value of 62 at this time. Then we move on to line 4, and what do we do on line 4? We decrease the value of x by 20. So it goes from 62 to 42. All right. And then where do we go?
3.
We go back to line 3, okay? We don't go to line 6. We have to go back to line 3 because this is a loop. The loop that we are dealing with right now is from line 3 to line 5. Well, line 5 itself does not do a single thing because its only purpose is to mark the end of the while loop. So when you're done with the body of a while loop, which is line 4, you have to go back to line 3 to re-evaluate the condition. And that's why we're going back to line 3 and evaluate the condition again. X is greater than 3 is true. So we go back to line 4. We take 20 out of 42, it becomes 22. We go back to line 3, x is greater than 3 is still true. Go back to line 4, 22 minus 20 is 2. We go back to line 3, x is greater than 3 is no longer true, it is now false. So where do we go next?
Line 6.
We go to line 6 because line 6 is sequential to the inner loop. In other words, if you look at line 3 to line 5 as one statement, it is the while statement. Line 6 as an assignment statement is right next to it. So it is sequential to the inner loop. Line 6 is going to subtract 1 from x. X goes from 2 to 1. And then where do we go now?
Post.
Back to 2.
We go back to line 2, not post yet, okay? We have to go back to line 2 because there's an outer loop, there's an inner loop. But regardless of whether it's the outer loop or the inner loop, you always have to go back to the condition, re-evaluate the condition to determine whether it is time to perform another iteration or to get out of the loop. So we have to go back to line 2 first to re-evaluate the condition of x is greater than 1. Notice that it is now false, and then we can go to post. Okay? So are there any questions about this particular trace? No questions? If there are no questions about this trace, we'll go ahead and look at the next question. The ABC are just variants of this one single question. So I'm going to move on to the next question. The next question is this one here. Observe the following code fragment. This one I'll ask you to work your way back up to the condition of line 3, and then work your way down again from line 3. In your test, I'm not going to ask you to work your way back up, so you will only be given the precondition and work forward instead of backward and then forward. So with this one, do you guys want me to do it the way the question is asking, which is backward first and then forward again?
Yeah.
Okay, you want to do it that way? Okay. Because it's not required. Your test does not have anything that goes backwards. Right? But it doesn't hurt. Okay, it definitely does not hurt to know how to do it. because this time, if I don't ask you this time, it means it's going to be in your final exam. I'm saving up all the good stuff for the exam, final exam. All right, so for this one, I'm going to use Notepad, just so that it's easier to type up the document. All right. Okay, so when you read the question, we confirm that the post condition of line 6 is, we know that x equals to 4, z equals to 5, and y equals to 4. There are two tasks to perform. One is figure out what is pre-3, and then once you figure out what is pre-3, then you have to use the derivations, not tracing, to prove that your pre-3 will result in the confirmed post-6. Okay, so the first thing we have to do is to go backwards first. So I'm just going to repeat what is posted 6 here. X equals 4, z equals 5, y equals 4. Can I say anything about pre-6? What does line 6 do? Y gets 4, right? Is there a way to reverse this to know the value of y before line 6? No, it's not reversible. Okay? So if it is not reversible, then we have to, quote unquote, forget it. In other words, we can keep the fact that x is 4, we can keep the fact that z is 5, but we can no longer claim that y is anything because we have no idea of the value of y before line 6. Is that okay? And we can use this to move on to the previous one. And now we can say pre-5 is, post-5 is pre-6 because these two lines are sequential. So this argument works also when you're working backwards. Okay, if the lines are sequential, you can say that the post condition of the line before is the same as the precondition of the line following. Okay. All right. When you look at line 5, it says z equals x plus 1. Okay. So let's take a look at pre-5 here. Can we say anything about x before this? If x equals 4 is the post condition of line 5, can we keep x equals 4 as a precondition of line 5? Yes, we can, and the reason why we can do that is because line 5
does not change x.
Yep, exactly, because x is not on the left-hand side. Okay. What about the other part, z equals 5? Can we keep that part? No. Can we claim anything about z? No. We lose track of everything about z. Okay. So now we can claim post 4 is pre-5. Post 4 is pre-5 and try to work out what is pre-4. What do you think? Line 4 is doubling the value of x. After the doubling, we get a value of 4. So before the doubling, can I claim anything?
X equals 2.
X has a value of 2. And this is the last step here. Post 3 is pre-4. Can we claim anything about pre-3?
Is y equals 2?
Well, we know one thing is for sure is y equals 2. Because x ends up with a value of 2 afterwards, so that means y must have a value of 2 before. But I cannot claim anything about x anymore, because line 3 is overwriting the value of x without any possibility of reversing it. So are we doing okay so far with how we got from line 6 the post condition of line 6 back to the precondition of line 3? Okay. If that part, no?
I'm good.
You okay?
Yeah.
Okay. So now that we know what is pre-3, we'll go forward again. Now going forward, I'm expecting full compliance to what we talked about for pre and post conditions. So there are several steps for each line that you have to do. The first thing is to identify what is the function. In this case, on line 1 or line 3. So for line 3, f of x. Okay, I'm going to do it this way. Okay. So f of x is y. There's no inverse function, so you have to tell me that there's no inverse function, and as a result of that, use the forget operation. To apply the forget operation, the post condition of line 3 is going to be something, possibly something forgotten from the precondition of line 3. Anything that I knew about x, I have to forget about it. But on top of that, I also know that x and y, should be the same at this point. So when you apply this operation, you have to find out what is pre3. We already know what pre3 is, which is this part here. And then we have x equals y after that. So is there anything to forget? If you look at the precondition of line 3, does it mention anything about x? Did I claim that I know anything about x before line 3? No. So that means the forget operation is kind of a moot point because I'm not, there's nothing to forget. I have y equals 2, I keep it that way, exactly that way, and then I have x equals y. Now in this case, I would also give you an optional step. The optional step is like this. If I know that something has a constant value, I'm going to propagate that constant value. Is that making any sense? If I know that y equals 2 and x equals y, I can also claim that x equals 2. Okay? Now there is a particular reason why this is important, because this helps me to break the dependency of the value of x from the value of y. So now that the value of x is its own, okay, I can make changes to the value of y without impacting the value of x, or without impacting what I know about x. Okay? So instead of writing it this way, let me see. I'll just call this option 1, so that later on I can refer to this. Let's move on to line 4. On line 4, I'm going to do the same thing. F of x, this time is x plus x, which is also known as 2x. We do have an inverse. The inverse function is as follows. F prime of x is x divided by 2, because doubling x has an inverse of dividing x by 2. And as a result, use the substitution operation. If I apply the substitution operation, the post condition becomes the result of a substitution operation performed on the precondition. In this case, I'm looking for occurrences of x and replace each one with f prime, the inverse function applied to x. So the first part I have to do is simply a copy and paste here. And then every x I find, I have to replace it with x divided by 2. So y equals 2 does not get affected. It does not mention x at all. X equals 2 becomes x divided by 2 equals 2. And that's the result of line 4. Are we still doing okay so far with line 4? Let's move on to line 5. On line 5, f of z, because remember the independent variable in the function definition is the left-hand side. It's the variable that we are changing. So in this case, it's f of z equals to x plus 1. It has no inverse because the right-hand side of the assignment operation does not refer to the left-hand side. If there's no inverse, we have to use the forget operation. That means the post condition of line 5 is potentially forgetting something in the precondition of line 5. Anything that we knew about z is maybe invalidated at this point. But after this, we can say that z is x plus 1. So when you perform the forget operation, the first thing we do is we copy and paste the precondition, and then leave the other part outside of the forget operation. I just want to use this opportunity to kind of point out that this conjunction with z equals x plus 1 is outside of the forget operation, not inside the forget operation. Some people forgot about this and z equals x plus 1 altogether. Some people put it inside the forget operation, which kind of defeats the whole purpose of the forget operation. Because if you put this inside the forget operation, it always mentions z and it always has to be forgotten. So remember, this is outside of the forget operation. Now we focus on the forget operation. This is the original precondition of line 5, It does not mention anything about z. In other words, I did not claim to know anything about z to begin with, so as a result, there's nothing to forget. I can keep the entire expression here, and on top of that, we can also now claim that z equals x plus 1. Now, in this case, I can apply the same trick again. In other words, I can now say that y equals 2, x divided by 2 is 2, but we can also rewrite this one as x equals 4. Is that making any sense?
Yeah.
Because I can multiply 2 to both sides of the equality. Z divided by 2 times 2 is x, and then 2 times 2 is 4. Okay. Now that I know x is 4 and z equals x plus 1, we can now claim that z is 5. Yep.
But is it wrong if we don't do that?
If you don't do it, it is not wrong, but you will end up losing more information than you need to when we move on to line 6. Because you will still have a, if I didn't do this on line 3, then we will still have a dependency of x on y. And then by the time we get to line 6, when we have to forget everything that we knew about y, we will also lose the value of x at that time. Yeah. So that's why we want to resolve, or once we resolve something to an actual constant value, we want to kind of spread those out as quickly as possible, so that the variables do not depend on each other anymore. Right. So moving on to line 6. Line 6, we define the function first. F of y is 4. No inverse, so we will use the forget operation. Host 6 is using the forget operation on pre-6. And this time we have to forget everything that we knew about y. But after that, we can claim that y equals 4, because that's the result of the assignment operation. I also want to use this opportunity to re-emphasize that we do not use a left arrow in place of the equality here. When we use the left arrow, it means it's an assignment operation. An assignment operation, at least in this class, does not give you a true-false value. It is simply saying change y so that it becomes 4. It is not true, it is not false, it is not Boolean. In this case, y equals 4 is either true or false, because y either has a value of 4 or it does not. So that's why in the context of a pre and post condition, we have to use y equals 4 and not y gets 4. All right. So let's go ahead and do some copying and pasting here. This time we do have something to forget, because in the expression in the precondition, we do have one component that mentions that y equals 2 here. So this is the one component that we have to forget. The other two components do not mention anything about y, so we get to keep x equals 4 and z equals 5. But on top of that, we also now know that y equals 4, because that's the result of line 6 itself. So is that okay? If there are no questions, I'm going to move on to the next one.
Hold on.
Oh, okay.
We don't have copy and paste option.
Yeah. Question. So on the basically where you do the equals forget and then the prefix, we have to show like those two lines. We just say no inverse use forget and then just skip straight to the last one.
I would still state what the function is, because this way, I know which function you're talking about. It doesn't take you much time to write it down.
I mean, basically, we skip from that first line here after line 6 to the second one and then to the last one.
Oh, you mean in the post operation?
Like, yeah, not right.
Skip writing all that down.
Yeah.
And it
Skip
gets
this one?
included automatically.
And the one above it.
And the one above
Yeah,
it?
can we skip those?
I would keep the first one, because that really is the template of using the substitution or the forget operation. The one in between, if you want to skip it, you can skip it, but I personally always, write it out just so that I know, I show all the steps, so in case, I make any mistake here, I only get a small amount of points deducted.
If we forget to write function of y equals such and such, or basically what that is for all of them, If we forget to write that, do we get points knocked down?
For the homework, it depends on how you state it. If you miss it entirely and you just start to use forget and substitution, then I might take some points off. In the case of a substitution, if your inverse function is correct, then I would still count it in as stating the inverse function, or at least implicitly saying the inverse function does exist, but you're still not stating what the original function is. So I do want you guys to kind of point out what the original function is, because that kind of makes it more step by step, and it's easier for me to follow your reasoning. Is that okay?
More structured.
Yeah, it is more structured. It's more mechanical, which is which is actually beneficial if it's more mechanical. Any other questions? Other questions? All right. So this is question number 2, and we can now move on to question number 3. Question number 3 is here. This is a cute one. It's 2 conditional statements inside a while loop. Okay, I think we should definitely trace this one.
Feel good about that.
Yeah, I got it.
All right, so let's go ahead. I'm just going to copy the whole program first. While x is different from y, do the following. Okay, in the test, you are expected to know the symbols for not equal to, conjunction, disjunction, and so on and so forth. Okay, so I cannot give you the definitions during the exam. You can bring any notes you want to. Okay, you can either handwrite something or print out something from the lecture and bring it with you. If x is less than y.
I get that. Go over something else. Make sure somebody thinks
This one is interesting because the way you trace the program may not be the same way as you go through the logic in your mind. So I'll explain that in just a moment. Okay, the first thing we have to do is to fix the indentation. Do you guys want to show me how to do it? Which block should I indent once first?
3, 7.
Line 2 to
7.
line 7. And then which lines should I indent one more time?
3 and 6.
Line 3 and line 6? That is correct. All right. Very good.
Yeah.
This by itself is a practice of indentation. Good practice. Yeah. All right. So now we are ready to trace the algorithm. And there's an initial condition here as well as a precondition, x equals 2 and y equals 4. Well, I mean, line 1 is okay too. That means
be pre.
Well, it doesn't have to be pre. This can be line 1. It's just that we have to complete the tracing of line 1 in this case, because line 1 is the beginning of a while loop. So we have to indicate, is it true or is it false that the condition, what is the value of the condition. So to get back to next, okay, I'm gonna get rid of this page. All right, so this is the algorithm we are tracing. So in the comments area, we still have to indicate, is the condition true or is the condition false? So we have to say x does not equal to y is true. Okay, very good. If the condition of a while loop is true, where do we go? We enter the loop, we perform the body of the loop, which is starting on line 2. Line 2 is the beginning of a conditional statement, which means we have to evaluate the condition itself. X is less than y is true. Then where do we go? line 3 is adding 1 to x, x goes from 2 to 3, and then where do we go? We go to line 5, that is correct. Now, why do we go to line 5? That's the first question. We are done with line 3 at this point. Line 3 is the only line inside the then branch of the conditional statement from line 2 to line 4. In other words, we do not have an else-if situation here. This is not a multi-branch conditional statement. This is a simple conditional statement with only the then branch. So from line 2 to line 4 is one conditional statement. From line 5 to line 7 is another conditional statement. And these two conditional statements are sequential to each other. When you're done with one conditional statement, you move on with the next conditional statement. Okay? So that's why after line 3, we get out of the first conditional statement, but the next conditional statement, starting on line 5, is the next thing that we have to perform. So on line 5, we compare x to y again. X is greater than y is false. Yep, go ahead.
This seemed have been replaced with like if, then else, instead of having two if thens.
Well, this is the way the code is written, so you have to trace it the way.
I'm just saying though, like could it have been written with just instead of two conditional statements, just one where it's if, else, you know, if it's less than else. Like if it's, you know, if x is less than y, then x gets x plus 1, else x minus 1, and then repeating the loop. It would have just been written that way.
Yeah.
If you rewrite that loop in that way, it is almost the same as this one, but
Yeah.
I would not say it's the same.
No.
Oh, it's not.
Yeah.
You know,
At
that-
least the way you're tracing it would be different.
Yeah.
Yep.
Because if they did it that way, then x equals y would be trigger the second one. X gets x minus 1. And
But
then
x
you
equals
never
y
get
cannot
out of the while.
But x equals y cannot be a condition, because if x equals y was true to begin with, it would not have entered the loop. So the way he suggested to rewrite the loop would have done the same thing as far as being able to exit the loop with the values that we wanted, but the tracing through the loop would not be the same. Okay?
Unless x equals 3.
Unless x equals 3.
Because if it equals 3 when it goes into the loop, then it gets
After
4,
one iteration,
then it
yep.
goes back to 3. And
Up in
then-
the second iteration, and it would become an infinite loop. That's correct. No. It would still exit, because x is different from y would be false, so you will still be exiting the loop. It cannot be an infinite loop. Yep.
The example question have a preset value for x and y? 'Cause
Some do and some don't.
I just wasn't sure.
Yeah, this one has an explicit starting value. Right? Okay, so now the big question is, what do we do after line 5? Line 5 is the beginning of the second conditional statement inside the loop. The condition is false, which means we get out of the second conditional statement right away without executing line 6. But the conditional statement is also the very last statement of the while loop, which means when we get out of the conditional statement, the second one, where do we go? We go all the way back to the first line. We all go all the way back to the beginning of the entire loop, which is on line 1. Okay? Is that part okay? So when we get back onto line 1, we re-evaluate x is different from y. It is still true. They are different. We go back to line 2. X is less than y is true. Go to line 3. We add 1 to x. X goes from 3 to 4. We go to line 5. X is greater than y is false. We go back to line 1. X is different from y is now false. And this is the last iteration. We get out to post. Are there any questions about this trace? Questions? If there are no questions about this trace, we'll look for.
Do you
go back to it for a minute? So
Oops.
finish the notes.
There you go. And I can do this part. Yep.
Can you put that file on so we can put the download so we can practice?
I think the ODT files may have the solutions already. Well, if not, it's all getting recorded right now too.
No, I mean the whole file so we can practice different ones.
You can practice on the different variants.
No, is the file available to download?
Yeah.
Oh, okay.
Yeah, but you do need 7-zip to open it.
Okay.
Yep.
You probably said it by common sense, but is it a handwritten test?
It's a handwritten test. Yep. Everything is going to be on paper. Okay. Any other questions about this one? Questions? All right. I'm going to move on to number 4. Oh, this is a nice one too. This time we don't have anything like this one, but do you guys want to go over that anyway?
Sure.
Okay. All right. So this question asks, is a particular branch reachable? And if it is reachable, find me a combination of values between x and y so that we can get to a particular line. Does everybody understand the nature of the question? So we look at lines 2, 4, 6, 8, 10, and 12 and say, can we get to those lines? If so, what values of x and y can get me to those lines? Okay. So to answer this question, one way we can do it, this one does not require a spreadsheet. If you want to use a spreadsheet, that's okay too. But does not require a spreadsheet.
We got 6 spreadsheets.
Is that the one? Yeah, we have 6. Well, we have 6 views. I think there are only 3 spreadsheets.
I think you should close most.
Yeah, that's okay. I'm just going back to my notepad here. There we go. All right. So let's take a look at line 2. What can get us to line 2? What combination of value in x and y can get us to line 2? Now you don't have to give me a unique solution. Obviously in this one there are quite a few values, especially with y, that can get us to line 2. Just give me one.
1.
0,
0, 0 will do it. Okay. X equals 0 and y equals 0 will get us to line 2. Does everybody agree that if x equals to 0 and y equals to 0, line 2 has to execute? Because the condition x equals to 0 or y is less than 2 is going to be true. Okay, let's take a look at line 4. What condition will get us to line 4? Now the first thing you have to do is to say the condition of line 1 has to be false even for me to consider the condition of line 3. So keeping that in mind, what do we have to do to get the condition of line 3?
6 and 7. You do 6 and 7.
6 and 7? Okay, so I would assume 6 is x and y is 7. 8 is going to work as well. All right. Well, first of all, let's double check. If x is 6 and y is 7, does it fail the condition of line 1? X equals to 0 is going to fail. That's good. Y is less than 2 is also going to fail. That's good. So the condition of line 1 is failing. And but at the same time, this condition will fit the requirement of line 3. X is greater than 5. Okay, that's met. Y is greater than x is also met. Okay, very good. Now, in case of a dead branch, you have to tell me there is a dead branch. What about line 5?
Dead
X
branch.
equals to 0 and y equals 3.
Dead branch.
Because it has to be.
It's
x
not
equals 0
necessarily a dead branch.
Really?
You can't, no.
Because it says
on the
and
first-
or,
X is 0,
so both
or.
have to be true.
On the first one, it's or. On
Yeah.
on that
The
one.
first one is
and
or,
it has
the
to
second
be
is
0
and.
and y equals 3.
So x would have to equal 0 and y would have to be 2 or greater.
No, y would have to be 3 now because you can't do
Okay,
that.
there's only one chance, right? Because we have equality on both sides. So the only one that can possibly fit this scenario is x equals to 0 and y equals 3. So now we have to see whether this condition, x equals 0 and y equals 3, is also going to be true on line 1 or line 3, because it cannot be true for line 1 or line 3. Is this true for line 1? Yep, because x equals to 0. Okay, so if we cannot make line 1 false in order to make line 5 true, then it becomes a dead branch. So line 6 is a dead branch. Is that making any sense? Because every time we have x equal to 0, regardless of the value of y, line 1 is going to be true, and when line 1 is true, we execute line 2, and with a multi-branch conditional statement like this, we take only one and only one branch. After we take that one branch, we exit the entire conditional statement. Go ahead.
Oh, no, you just answered my question.
Oh, okay. Great. All right, if line 6 is a dead branch, does it automatically make line 8 a dead branch too? Not necessarily. Okay, so let's take a look at line 7 and see if we can find out why it is not necessarily a dead branch. It looks awfully similar to line 3, but what is the difference?
There's an or.
There's an or, and the other one has an and. So this time we have a more restrictive case on line 3 and a more general case on line 7. So on line 7, I can either make x greater than 5, and then I don't really care whether y is greater than x or not. Or I can make y greater than x, then I don't really care whether x is greater than 5 or not. Okay? So pick one and make it work.
7 and
4 and 5.
Sorry?
7 and 6.
7 and a 6. Okay, you have to tell me which one is 7.
X would be the 7,
Okay.
and Y would be 6.
X is 7 and y is 6. Would it fit the bill? Okay, the first line is going to fail. The third line is going to fail as well. And then line 5 is going to fail. So line 7 is the first line that will be true. Okay, very good. Is everybody following the reasoning, how I double check? Because it's easy to come up with a quote unquote potential scenario that will fit the condition. The question is you have to go back and check to make sure that it does work in all cases. Okay, so we have only 2 left. Let's look at line 10. Is line 10 possible? Can we get to line 10 with x greater than 0 only?
Yes.
It should be possible. X is 1 and y is -1. Would that fit the bill? Well, we can check one. We can check it sequentially. Okay, so let's take a look at this condition here. Will the condition of line 1 be true?
Yes.
Oh, it is true.
Yeah.
Because y is less than 2. So y cannot be less than 2 and x cannot be 0.
Y equals 0.
But Y
Oh,
is
yeah, yeah, less than 2 is true.
How about that?
X is 4
I think this might fit the bill too. Okay, let's double check. So if x equals 3 and y equals 2, then x equals to 0 is false, y is less than 2 is also false, line 1 is going to be false. The condition of line 1 is going to be false. We now check the condition of line 3. X is greater than 5 is false to begin with, don't have to check anymore. On line 5, we have x equal to 0 and something else, x equals to 3, which makes x equal to 0 false. We don't have to check anything else. On line 7, x is greater than 5 is false. Y is greater than x is also false. So that entire disjunction is also false. So now we are on to line 9. X is greater than 0 is true. So it will execute just fine. Okay, so it's not a dead branch because we can create a unique situation to make that condition true. What about line 12? Can we get to line 12? Okay, so if you look at all the requirements on x, everything about x is 0 or more than 0 is already covered. So the only thing we can do is now to make x negative. Okay, so we'll go ahead and try and say x is -5. And we also want to make sure that y is not greater than x, because if y is greater than x, it's already covered by line 7. So we will have to make y less than x. So -6 will work, or -7 will work. Okay, let's double check again. X equals -5 and y equals -6. Sorry? Doesn't work for line 1?
No, it doesn't.
That doesn't work.
Because y is less than 2 already.
wouldn't work for
So
y.
nothing is going to work.
It's a dead branch.
It's a dead branch. Yep. So we have 2 dead branches here, and one is the last case, and the other one is right in the middle.
Funny how that works.
Okay. So are there any questions about this sample question? No questions?
Just like the logic on how to first approach it, maybe.
You mean how to come up with the values? Well, it's still just the application of logic. You have to kind of come up with. It is still generate and test. This is an approach that I call generate and test. You look at these scenarios and go like, okay, maybe this will work. Okay, you create the case, and then you have to double check and see if it works or not. And right here, the last one, or line 12, is a dead branch because of this requirement and also this requirement. In other words, I have to look for something where x is less than 0, because if x is 0, it's covered by this case. So x has to be less than 0, but y also has to be not greater than x, but less than 2. So those restrictions, basically said, okay, I cannot find a pair of values that can fit the requirements. Okay. Are there any other questions?
What if y didn't have a value at all?
Y cannot not have a value.
Like maybe there's something previously in the algorithm that stated that if something is true, then we give it a value. Otherwise, it's not needed and it's completely not.
Now, since you're moving on to cisp360, a particular variable always has a value. So you cannot have a variable without a value. In some programming languages, you can have a non-value for a variable that is not initialized.
Essentially a possibly dead variable if it's not needed.
Yeah, there's no such thing in C programming. In C programming, if you have a variable y and it's an integer, it always contains an integer value. Now, whether you know what that value is at any particular point of your program is a different question. Okay, but it always has an integer value. But in this case, regardless of the value of y, we cannot get to line 12. It's just not possible. Any other questions? No other questions? Right. Let's go back to this part here and see if we have any more sample questions. Nope, that's it. Well, I can go over the title page too. The title page is really it's about the same from one semester to the next. Expectations is to work individually, independently, and originally. No electronic tools other than simple calculators. Can use any material, either handwritten or printed prior to the exam. No live help in any form from anyone during the exam. I talk about the code tracing standards here as well. Nothing really new. Pre and post conditions and point allocation. For this particular exam, they do not carry the same point values. So the first thing you might want to do is to quickly go over all the questions and find out which one you feel most confident with first. Okay, always do that one first. Even if it's a low point value question, if you look at that question and go like, oh, this is easy schneezy, start with that one. Okay, so you're done with that one. You pocket a few points already. Okay, and then you move on to the next one that you feel okay. I think this is the next easiest question. Deal with that one first. Okay, you always leave the most difficult questions as your last questions. Even if those questions have a lot of point values, you still start with those last. Well, at least that's the way I would do it. And you guys can obviously choose whichever way you want to handle your questions. But does it make sense, to start with the ones that you think are the easiest first? All right. So are there any other questions about the exam? Yep.
Oh, when is the exam?
On Thursday, same place, same time.
Is there only 4 questions?
Hmm?
Is there only 4 questions? Like
about 4 to 5.
It's this Thursday?
Yep.
You said we wouldn't need to bring any paper unless we wanted extra to write on, right?
I would just bring a few extra sheets of paper just as spares, just in case you need it, then you don't have to look around and ask somebody for it. I can bring some binder papers too, but I have not used a binder for years.
If our notes are in our notebook, we don't have to rip them out, do we?
Say again?
If our notes are in our notebook, we don't have to rip them out.
Nope. You can bring an entire notebook if you want to. Yeah. It's open book, open notes. So if you want to bring anything that is, the only requirement is whatever you write down during the exam, you cannot pass that material to other people during the exam. That's the only requirement.
Get all the stuff out of my phone then. Because you said we can't use any electronics.
No electronics, right? You'll have to print it out.
So no open PDFs.
No open PDFs, right?
Can I type my notes, print it out, and bring it?
Yeah. As
Okay.
long as it is printed or handwritten, it's good.
Can we just walk up to the whiteboard and write a bunch of stuff?
Can you walk up to the whiteboard and?
That technically is a hole in the logic.
Well, but it does not meet some of the requirements, does it? Because it says, handwritten or printed prior to the exam. So
But
if
you
you walk up to the whiteboard, it would not be prior to the exam.
But you just said that we could write stuff during the exam on like separate. You said when you were talking to him about not writing stuff.
Does that meet the criteria?
I think the bigger question is, you don't want to give anyone, a chance to look at your answer, so that, it becomes a problem of sharing answers.
Unless it's a wrong answer.
Oh,
Sabotage.
Sabotage. I know that person is looking at my question, so I'm going to write something
It's gonna
in
bomb us.
big and clear, font to make sure that person can read it.
Can we do one more pre-post?
One more pre-post. I don't know whether we have any more of these things online. Okay, so here's exam 1. This is X1. Oh, this one is not visible to you guys. I'm gonna have to.
Where is the file with all of the
Where's the what?
Where's the folder, all the files?
I just opened it up.
Oh.
Yeah, so it should be visible now. And let's see, this exam 1 archive. this one I have given you the solutions already.
Well, most days.
Yeah, here's another pre and post condition. So this one is kind of like derive the post condition of the last line of the following pseudocode. Be sure to show and explain all steps. And the precondition of line 1 is just true. But remember, I'm not going to ask you guys about conditional statements, not for the first exam. So this one is not going to be exactly the same as your question. So it may not be as helpful as your own homework assignment due last Thursday. That one is going to be useful. Any other questions? No other questions? Okay. All right. And I think for a typical exam, for any of my classes, cramping is not going to work.
You mean cramming?
Cramming, yeah. Sorry. Cramming is not going to work because it's not about memorization. There's nothing, in this class that is about memorization. Otherwise, I would not have, you guys write your notes and bring your class notes and anything that is printed ahead of time. So it really is all about understanding the material. You might want to still bring along, my notes, just in case you need to look up, okay, what is this symbol representing? Okay, this is a typical thing that people ask me. Okay, what is this representing? Or later on, we'll have other operators, and people just forget one or two operators. Yep.
I know I could look it up, but could you remind me which one, the or and the and, or the upwards and downwards carrots, right? I don't remember which.
This is and.
Okay.
This is or.
Right.
So you can write down on your notes too. You'll just have a little table to look it up.
Are
the
you going to use
definition.
those specifically? In the test?
I tend not to use these in traces, but in the pre and post condition thing, I might start to use those. But it is good to know. Okay, it is a part of the material of this class. So that means in your when you prepare the notes for the exam, you can kind of have a little table of operators. Any other questions about the exam? Oh, pass the roll sheet. Okay, I did not print a new one, so this is going to be another column, on this sheet here.
First one is the and.
But you're in the earlier class, right?
The first one's an and.
This is and,
Okay.
this is or. Yep. All right, so if there are no questions about the exam, we'll go ahead and move on to top-down design and see where we're at. All right, finally, we're back to top-down design. I think last time, I showed you guys a picture of someone laying out a program listing using fan-folded paper, and it was really long, and I talked about how some people actually use long rulers to help line up the beginning and the end of a construct, so they can actually see, oh, this is the end of a while loop, and there's the beginning 4 pages earlier, right?
If only they had colored, different colored print for each indentation.
Yep, or you can draw lines to indicate, I typically draw a little bracket like this at the beginning of a construct and then end, with a little bracket here. So this way I can match the beginning with the end here. So anything that's nested in between would be like this, like that, okay? But you don't want to deal with programs that long, okay? It really is not easy to track.
Not that you'll have a choice.
Well, I did not have a choice, but I did not ended up doing it either, because I rewrote that entire subroutine from scratch. I kind of know what it is supposed to do, and I just said to myself, okay, I'm going to redo this entire thing from scratch.
On scratch.
Hmm?
On scratch.
Using Scratch. Yes. All right. So what we'll do is we're going to use a particular programming example to illustrate the whole purpose or the whole idea of top-down design. And how do we actually use that particular concept? The example is using factoring. Now you're supposed to read the notes ahead of ahead of time, so I'm not going to read the notes itself. But what I will do is I'm going to explain what factoring is first. We'll do it by hand a few times, and then we'll go ahead and do and write the algorithm. And for that purpose, we are going to use Notepad. Okay. All right. So let's go through a few examples of factoring. And I'm hoping most of you still remember fractions and stuff like that, so that you still remember how to factor a number. We'll start with 75, okay? When we factor a number, now most people can look at 75 and say, oh, I know about 75, it is 5 cubed. Well, that's entirely correct. No, it's not 5 cubed, it is 3 times 5 times 5, okay? But most people can look at a number and actually factor it like right away, okay? So, but I don't want to do it in a single step. I'm going to factor one prime factor at a time. So I will extract 3 as a prime factor, and then I'll say, I'll process 25 later on. Is that making any sense? And then I look at 25 and say, well, 25 is 5 times 5. I look at the second 5 out of the 25 line, and I say 5 is 5 times 1, because the factor of 5 is 5 itself. It is a prime number. Okay? Is that making any sense? All right, let's try another number. Let's try this number here and see if we can. I just randomly pick some key on the keyboard. It might end up to be an easy one. Okay, that's 11, 13, 21. Oh, it's certainly not divisible by 3. Okay, so how do you find, all the factors of this number? How do you find the first prime factor of this number?
Keep trying to divide by prime numbers.
Okay, very good. Okay, so let's go ahead and try that. And of course, since I have tools to help me, I'm not going to do it by hand. This is also why spreadsheets are handy. Okay, so the number is 472871. Occasionally, I can just type something like this, and it ends up to be a prime number itself, but it's unlikely that this is going to be a prime number.
Yeah.
Do you know how hard it is to find a large prime number?
There's a job out there for that.
Exactly.
That's how hard it is.
It's for encryption purposes.
Mm-hmm.
Yep. All right. So we'll go ahead and we'll go ahead and take a look at how do we know this is a prime number or not? Okay. So we'll look at 2, and then we look at what we call a mod operation. A mod operation is basically the same thing as a division, except we are not interested in the usual thing that we are interested in. In a normal division, which part of the result are we interested in? The quotient or the remainder? The quotient, okay? Most of the time we are interested in the quotient. In this case, we're only interested in the remainder. So that's why, we're gonna say the dividend is still the same thing here. The divisor is going to be this number. Okay. And after the mod operation, it is a 1. I'm gonna change here, this part a little bit here. By putting a $sign, that becomes an absolute reference.
Absolute value.
Absolute reference. Because otherwise, it will try to shift to the next cell, and this way, it's not going to shift to the next cell. Okay. All right. So we'll go ahead and do it this way. Okay. I know it may not be the smartest thing to try 4 as a potential factor of this number. Would it be wrong to try it? In other words, is it possible that I would identify 4 as a factor of this number mistakenly?
I don't think it would, because it ends with a 1. Even numbers don't go into odd numbers.
It cannot be exactly, okay? So the answer is no, I cannot accidentally identify 4 as a factor of this number. Because if it's not divisible by 2, it cannot be divisible by 4. So by trying out 4, I'm just wasting my time, but I cannot come up with an incorrect answer. Okay. So sure enough, it has a remainder of 3, remainder of 1, 5, and so on. Oh, okay, we just found one factor, right? 7 is a factor of that number. Cool. So I'm gonna say, but what is this number divided by 7? Okay.
We're getting close. We're getting close.
7 times 67553. 67553. All right. So the next number I need to deal with is 67553. Is, well, let's find out. I'm gonna use the same trick here, right? We'll start with 2. Is it wrong to start with 2? In other words, can I come up with the wrong answer if I start trying with 2 as a potential prime factor?
Yeah. You could get it wrong.
Well, if assuming my arithmetic is not wrong, the method itself is not wrong, okay? It may be a waste of time because we have heuristics or rules of thumb that says if the least significant digit is not divisible by 2, don't bother with 2 because it cannot be divisible by 2. But those are rules of thumb that we have learned over time, okay? Which means if I do not apply the rules of thumb, I'm not going to be wrong. I may just be wasting some time, but it's not wrong either. Okay, so I'm going to do the same thing here. I'm going to use the mod operation. Once again, it is a division. That is my dividend. This is my divisor. And once again, I have to use a dollar sign here so that it would refer to the row number in an absolute way. Okay. So after this, I can now apply the same trick. And no luck so far. But this is why I like a spreadsheet, because it allows me to do this.
It's a lot faster than if we did it by hand.
Oh, 43 is 1. I got a winner. Okay, so if 43 is the next factor, so that means I have to figure out what is the remaining portion. It is 1571, 1571. So now we look at 1571 and see whether it is, see what prime factor it has. Okay, so let's take a look. Apply the same trick, starting with 2 as a potential factor, and then use the mod operation. And change the E49 to $49, so the row number does not change as I copy that row, as I copy that cell around. Okay.
Until you get past 43.
Well, I'm pretty close to being done here. Once I get to 40, I can stop for sure. Okay, that thing is a prime number. How can I stop so quickly? Okay, let's think about it. Actually getting to 40 is already too much. I could probably stop just a little bit earlier. But 40 times 40 is 1600. And 1600 is already more than 1571. And that's when I can tell this number is a prime number. Now, how can I tell so quickly that this is a prime number?
You just said.
Sorry?
You just said.
Okay, let's look at it in a slightly different way. Okay, I can come up with this theory that it's a prime number because I have tried all the numbers already that can potentially be prime factors. Okay, but tech, you just tried all the way up to 40. How can you stop right at 40 and say that there's no prime factor for this number other than itself? Let me ask you another question. If I have a product P, and it is the product of n, which is an integer, and m, which is an integer, just for now, we just assume that n and m are both positive. Okay. Can we have any particular properties related to n and m? This implies that n times n is less than or equal to P, or M times M is less than or equal to P. Does that make any sense? It's a disjunction, okay? We gotta be very sure that this is a or, not an and. Okay? If I have a product P, n is a positive integer, m is a positive integer, then one of these two has to be true. It can both be true at the same time if P is actually the square of an integer. But at least one of these has to be true. Okay, let's try out. Okay, let's try out with a few actual numbers. Let's try out with 45. Okay, you can express 45 in many different ways. I don't even care about prime numbers at this time. Okay, so 5 times 9. Okay, 5 times 5 is 25, and 25 is less than 45. Okay, I only need one side to be true for the entire thing to be true, so it works out. Let's try 25 then. 25 is 5 times 5, and once again 25 is less than or equal to 25. In this case, we have both sides of the disjunction being true. Okay. Can you find me a case where this statement is not true? Find me a product of two positive integers where if you square each one, the square of each factor is greater than P. That is what I'm looking for. Now, just because you cannot find that number in the next 3 minutes doesn't mean it does not exist, right? But all you need is to find one counterexample to prove me wrong. Okay. So what are we going to do with this one? Can we just say that, well, since we cannot find a counterexample to what tech is claiming, then we'll just say that, oh, this has to be true. Did I share with you my graduate school adventure about how my dissertation was based on the theorem of somebody else's master's thesis, and it turned out to be wrong?
Not in
Did
this
I?
class, but I've heard.
Not in this class? Okay, I think with 2 minutes remaining, I can just tell you that story instead. Okay, so this is back in graduate school. I was just starting up with my own dissertation. I was about maybe 2 or 3 weeks into my dissertation out of 2 years, okay? So it's not a big deal, it's like at the beginning. But I did not feel comfortable about a particular theorem that stated this blah, 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 blah has to be true, okay? So I asked my advisor, can I see the proof of this theorem? Can I see a step-by-step mathematical proof? My advisor said it is already done by somebody else's master's thesis, so go look it up. I looked it up. There was no proof. The statement says obviously blah, 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 blah has to be true. That to me is not a rigorous proof. Okay, it was just somebody claiming that it is obvious that this has to be true. I didn't buy it. I spent about 1 week to find a counterexample to prove that theorem wrong. Because to prove something wrong, all you need is to come up with one counterexample that contradicts what the theorem itself is claiming. I brought that counterexample back to my advisor. My advisor only had one response. Oops. Because he was on the committee of the master's thesis as well. Along with my other 2 advisors, or my entire committee was actually identical to the committee of the master's thesis. So there wasn't much I can do about it, except to go back to my lab and tell my other lab mate and say, guess what? This theorem turned out to be wrong. And he just went ballistic because he was at the end of his own master's thesis project based on that very same theorem. I was just starting, so to me it was like, maybe 1 week's worth of time is gone. It's like, no big deal. But he didn't really quite feel the same way.
He wasn't so carefree about it.
Exactly, but that kind of that shows you why it is important to prove something in a more rigorous way. So we'll do this, on next Tuesday.
Make some way to check that out.
Thank you.
Your sorrows.
Oh.